Thank you, everyone, for coming. My name is Philip. I'm a software engineer here, and I am very happy that Leo is coming to speak. So Leo and I were we were in grad school around the same time, and we were actually office mates one summer at another unknown company, and we just had a really good time that summer. I mean, Leo has really impressed me by both the breadth of stuff that he's really interested in terms of research engineering, and also the depth in which he goes into stuff. So he's one of these rare individuals that has a lot of diversity and breadth, and also, this is one of his several projects that he goes in with a good amount of depth. So I'm really excited for this talk, and I hope everyone else is as well. So go for it.
Phil didn't say he's also like that, but okay, yeah. So hi, I'm Leo. I'm from over East Bay, UC Berkeley, and this is work I've been doing with Ari Rabkin, who was at Berkeley, now is at Princeton. And we've been looking at programming language adoption. I'm going to be talking about two different ways we've been looking at it. One is about quantitative analysis, and the other is actually looking at kind of what the sociologists might say to us and seeing if we can sort of cherry pick theories that apply to our domain. So before I get into what that really means, I want to kind of ask, like, why do we care? Like, how's this interesting to us? And so for that, there's a really cool paper by Eric Meyer where he found this principle called the change function. This is by Pip Coburn, and to sociologists, they actually call it something called a switching cost, but neither of them appear to have known that at the time. But basically what it says is if you're looking at some sort of new technology, it's going to have some benefit, and when that benefit is greater than the cost and kind of that pain of going through that adoption process, then it's a rational choice to go forward. And you might not have known the guy who's talking about, Eric Meyer, but you probably know the language that he's one of the key designers of, which is Haskell. And when he looked at this change function, he realized, okay, Haskell has all this functional programming goodness, but you also have to pick this new language, and there's a lot of pain involved there. And what he decided after that is that from now on, my goal in life would be to also drive the denominator down to zero. And what he meant here is that instead of doing all this cool functional programming stuff and designing these new features for Haskell, he'd actually join the Visual Basic team, do all this cool new functional programming research there, but do it in that same language that is sort of easy for developers to already use and kind of lower that kind of cost of adoption. So what I want to talk about today is kind of two different ways we've been looking at how adoption goes and how we should think about adoption. And by we, I mean language designers, language researchers. And we've been looking at two ways. One is doing kind of large-scale data analysis of actually going out into the wild and seeing how this stuff actually happens. And instead of just doing kind of this like random safari of just looking at random facts, we've been trying to keep all of our work informed by how actual sociologists look at adoption in general and in particular fields that are somewhat related to languages. So let's first talk about kind of the fun numbers, and then we'll get to the models behind it in a bit. So when I'm talking about adoption, I'm interested in actually two things. One is a language like Haskell, but also another thing is like a feature like functional programming. And throughout this talk, I'm going to kind of switch in and out of those two different types of adoptions. And we've done a lot of cool quantitative analysis, but here I just want to talk about three particular types. One was we want to look at how people pick domain-specific languages over general-purpose languages, which matters when we're trying to pick what type of language to design. Another thing is kind of in the small, when a programmer makes one small decision, how did they actually make it? And then finally, as an educator or somebody who wants people to know languages, we're interested in what actually influences people's ability to do so and what's important there. So let's talk about domain-specific languages first. So when I say domain-specific language, I mean something like Excel, which is good for maybe doing accounting formulas. And then there's this sort of the spectrum that you can make it more and more general, which is something called general-purpose languages. And oftentimes we might say this is something like a Turing-complete language where you can compute anything you want. So maybe there's like a library for everything in Perl. Like you just have to look for CPAN and find it. And then there are kind of, and this is like a spectrum, maybe something in between is like MapReduce here at Google, where you can plug in whatever function you want into your map and reduce, and it'll just run it on the cluster. But this is sort of, might not be actually a good way to think about this stuff. So what you're seeing here is one of those experiences that scarred me as a youth. I went to a soap factory to see how they make soap. And apparently, they run the SOAP machines by Excel macros. So this is a very domain-specific thing, right? So maybe this is not, like, maybe we don't actually even know what we mean when we say domain-specific. So we took a look at about 200,000 projects in SourceForge and tried to understand what does it mean to be domain-specific. And for each project, we had a few pieces of information. So here we're looking at I guess it's the Squirrel SQL client. On the bottom left, we're seeing that this is it's a client, it's a front end. So it's the category of front ends. And then on the bottom right, we're seeing the programming language is Java. So you're going to write this type of front end in Java. And so we see what else do people use Java for in SourceForge. And so what the chart you're seeing here is on the x-axis different categories. So one of those dots means blogging, and another one of those dots means you're writing some sort of search program in Java. And what the y-axis means is that wire means it's more popular for that particular category. So if somebody's going to write a search client, it's actually about 40% chance it'll be in Java. But if they're doing blogging, it'll only be like, I don't know, 10% chance that it's in Java. And so this is in just the SourceForge repo. So I'm going to say, if you're one of those 200,000 programmers, this is specific to that. What's cool is I actually started life as a schemer. And there, it's fun to look at the adoption, how niches work there. And there we see, okay, so apparently build tools is something people relatively, if you're going to use Scheme, it's going to be for a build tool. And if you notice, though, the y-axis is actually a little different, like it's smaller. And what the really interesting thing here is that you don't have this nice spread of Scheme across different languages, right? It's like a few things pop out. And so what I did next is, or Ari and I, we actually ordered the languages by popularity. So Java is there on your left, and no, that's the popular one. And then Scheme is on the right, and maybe not unpopular, but underappreciated. And so here we're seeing just general popularity. And then what we added it in was the standard deviation across different categories. And notice that the y-axis here is actually on a log plot. And so what that means is even though they all kind of look the same size, because the standard deviation is kind of at a lower point on the bottom right, that means it's much smaller than the ones on the other side. And so, for example, if I divide standard deviation by the average, you actually see, like, or maybe another way of looking at it, if you look at those two slopes, they're kind of changing at a different rate. And so what that means is standard deviation. All right. So the interpretation here is basically, as you get more unpopular, you're only going to be kind of showing up in certain niches. It's sort of what we saw for Scheme versus in Java. And so that kind of leads to a certain type of thinking. For example, when you're going to talk about language adoption, you're not going to say that it's getting generally more popular. It's getting more popular niche by niche. Like you're going to see more of those popping up, and like all of them are going to go up. But also the cool phenomena there is you start seeing this pop. And I'll get it back into that later. But like now this is already leads you into a whole new line of reasoning about how languages work. So this is all very high level. So let's actually zoom in a bit. So we can ask, well, how do programmers actually pick languages? And here we see a picture of a bunch of dogs where we say, no matter what it is, we want it. I think better of programmers. And so I was curious what they actually do. So here, again, we're looking at SourceForge, the same 200,000 projects. And what we're seeing on what you're seeing on the right is just kind of a project that the most recent, or second most recent project they wrote. And then what you're seeing on the bottom axis is, given that project, what's the likelihood of them picking a language, some next language? So given you use one language for a project, what's the likelihood that you're going to use some other ones? So kind of as an example of what's going on here is no matter what language you picked on that right axis, on the y-axis, you see these vertical strips that good chances are you're going to pick any one of those, like one of those 6 languages. So probability that is sort of independent of what language you use, you're going to probably use one of those 6 bars. And so that means programmers are a creature of habit. You're going to use a popular language. What's also cool, if you notice, is there's another phenomenon going on here, which is we have this very strong diagonal in this matrix. What that means is you're going to use that same language. Like you use one language, you're going to the next time, a good chance the next language you use is going to be the same exact language. So now we're actually even more strongly instilling that programmers are a creature of habit in 2 different ways now. And this actually characterizes most of the projects on SourceForge, is programmers use the same language, either that's a popular one or that they used before. So kind of this led us to a question of why. I'll explain this in a second, but why are they a creature of habit? What actually led to those decisions? Is it just they like popular things, or is there something else going on? And so we launched a bunch of visualizations of this stuff, and we realized that, oh, this might be a nice opportunity to get our work in the eyes of lots of other people. And in this case, you see we got slash-dotted, and as soon as we put up those visualizations, like we were talking to the press, and it's all really fun. But what was really going on here is something different. It was much more insidious. Was actually we wanted to run a survey. And so the reason we did this viral campaign is we wanted to see if we can ask programmers about how they actually picked projects for the most recent project. And so in about a period of 2 days after this campaign, we had about 1,600 responses from people on websites like Slashdot and Wired. And so what we're seeing on this graph is what they said. So this is a little noisy graph, but basically what we're seeing here on the bottom bar is different types of reasons people pick the language for the last project. For example, the very strong influences are the bars under the green arrows. So for example, on the leftmost, actually open source libraries were from a strong to medium influence. So everything above that horizontal black bar. And then also something like group legacy, which is sort of what we're seeing in the SOURCEFORGE case, is that the group was already writing code in this language, so the next project will use that same language. And what's really cool is that as we go through all these green bars, for example, self-familiarity, team familiarity, open source libraries, these are all about social properties of a language. This is how other people use the language. It's not just about how fast the language is intrinsically. And as a language designer, then I started asking, okay, well, what about the other? What had slight influence on what languages were picked? So on the leftmost, you see something like correctness, that would be like type safety, or one of those like very common properties. Or and more dear to my heart is something like developer speed or productivity, that like inherent productivity to the language. That actually was not a strong influence for picking a language, like when you actually get down to a concrete decision. So the programmer is an interesting social beast. So this is just like me asking all the programmers and showing that. So the question is like, what happens when we start picking what programmer we look at? And so if social properties are very important, we can start asking what happens when we look at different types of programmers and from different types of social organizations. And so what this chart is showing is those same axes on the bottom, like those same properties. But now I'm slicing the programmer data based on what size company does that programmer work at. And so the leftmost, like that dark blue, will be like you're working for yourself. It's a one-man team. And the rightmost will be you're working for a 500 organization with 500 programmers or more. And just as just kind of like a quick surface representation, I asked what's the slope of the curve across these. So for example, if we look at correctness on the left, I wrote a green plus, and that means that the bigger the organization, except for one of those bars, it basically means that the bigger the organization, the more that correctness is a concern. Well, if we look at something like open source libraries, the first red minus, that's kind of a negative slope. And what you see is the bigger the organization, the less that open source matters. And presumably, they're building their own software. And these are actually significant. These are significant changes in adoption habits, because this is essentially going from median influence to a slight influence. This is a full 1-point drop. So just kind of in summary, larger companies care about more social properties about their language or how the language is used. So the size of the company is just one way of looking at of kind of bucketing programmers. And so there are lots of different types of programmers out there and lots of different ways of looking. And so one thing that actually that we've been looking at actually was partially inspired by Philip was actually education. And so we're wondering how does education and age and things like that play into the languages you know? So as one example, we did actually another survey, this time on something called a MOOC, a massive open online course. And this is essentially, you can think of it as a programmer who's in the job force but wants to take an online course. And so this is kind of an educated programmer, somebody interested in languages. And we were able to get about 1,000 or 2,000 programmers this way and ask them about how they learned languages. And one interesting phenomenon we found out is that the number of languages a programmer knows, like once you're 20 or older, is sort of stagnates. Like you'll say that, oh, I know what those red bars are seeing so the x-axis is age. So as we look from left to right, like the red bar is kind of constant, right? Like we have this nice line in the middle. The number of languages you've used actually stays kind of dormant, independent of your age. And the number of languages you know well is the green bars, and that actually also stays fairly invariant. And again, these are educated people who are working programmers. So if we are going to do something about language education, it sounds like what's going on after you're in the workforce today is rather stagnant. So we took a look at what happens in school. It's like what we do there matters at all. And so what we asked is, if you look at the labels on the left column, there we asked for different categories of programming, like functional programming like Lisp and Scheme, or dynamic programming like Perl and Python, or maybe specialized systems like assembly or like MATLAB and Mathematica. For each one of those categories, we wanted to see how you acted in school influenced how what languages you know today. And the first thing we looked at is whether you're a CS major or not. Is CS education actually doing anything at large? And there what we found is when you ask CS majors versus non-CS majors about the languages they know in these different categories, that actually doesn't really matter. For example, non-majors 19% of the time will know about functional programming, and CS majors will know 24% of the time. So there's like a small 5% jump. So as somebody interested in education, this is a small jump. However, if we look at whether a particular language was taught in an individual course, like in one of these families, now we see significant changes in the statistics. For example, for functional programming, that top row, if you were taught it one of these languages, you'll say that you know it 40% of the time. But if you weren't taught it, you'll only have picked it up after school about 15% of the time. So the kind of takeaway here is like it actually doesn't matter to a large extent whether, like, if you don't know anything else about a person, whether they were a CS major or not. But if you actually ask what was taught in those particular courses, that's actually now that becomes significant. And when we define a CS curriculum, the languages we teach actually matters, because otherwise apparently people won't learn them. So I actually have lots of statistics. If you go to my website, like the URL is here. We actually have a few interactive visualizations, and this is actually the thing that launched our viral campaign. And also, our raw data is up. If anybody knows statistics much better than me, I would be curious to see what you have to say. And with that, actually, I wanted to move on to the kind of the social principles, the kind of more theoretical stuff. But before then, I think this might be a good point, the stopping point, if anybody wants to ask questions about this more quantitative analysis.
In the previous slide, you have no entrance for C or C++ or static type languages.
Yes. So we have that data, but I suggest you come up to me after, and I can pull it up. This is just like a snippet. Also, I think for those, like, people use those in practice, so I don't think it's as surprising. Mark?
On the number of languages versus age,
Mm-hmm.
There was never an upward slope, even at the beginning of the graph. So that doesn't seem to support the hypothesis that people tend to learn languages before they get up.
Yes.
It seems like as soon as they're qualified to be on the graph at all, they're already stable.
Yeah, so I think, our first guess here was that we had some sample bias going on. And actually, the first graph time we did it was actually for the Slashdot survey. So we figured we were just asking a bunch of nerds about nerdy things. And that's actually why we went back to the online course, because there we actually had much wider demographics. And so here, I actually think this really is what's going on. But maybe what's going on is somehow, maybe, for example, how we asked the question, that maybe somebody isn't remembering languages. But one of the ones we asked was, we actually gave reminders of different types of languages, and then we actually asked them to, we tried different ways of asking the question, like, can you enumerate your answers, and can you actually just give a number? In both cases, we kind of saw the same stagnant. So I'm actually, this seems close. Yeah.
Could this be because companies pay employees to take classes, so they end up using that?
Yeah, so maybe a good thing to do would be to do some more of the demographic slicing. For example, we had a lot of international students in this particular survey, so that'd be interesting to control for.
Also, you're assuming that a snapshot of ages at a given point in time is a good indicator of what would happen if you followed a programmer over the ages of the same program. But it might be that that the conditions for being 20 now are different than the conditions for being 20 years ago.
Yeah, so there could be, the computing industry could change, and that will, so maybe these are statistics of the day. These are cross-sectional, not longitudinal. Yeah. I've actually found indicators that that's actually not the case, but I think we should talk offline about that. But basically, essentially, as soon as personal computing happened, then ages became invariant. But I'll talk about, we can talk about that offline. I think in the back.
Is there any indication that the set of languages that a 20-year-old programmer knows well is going to be the set that he's going to know well?
So this is cross-sectional, meaning we took it at a snapshot in time, so I really don't know. But what I will say is that we actually looked at different age groups to see what languages they know. Then, for example, if you're in college and you haven't left yet, this is the time to learn Ruby. Like you're like a Ruby programmer. But if you've already left, you've missed the curve, and you probably won't know Ruby, even if you're just like 2 years older. So like there definitely are cool like age-specific phenomena. John? Yeah, so the question is, are kind of languages somehow generational, that like, when Java came out, like you have the Java generation programmers. I don't know. It sounds like that's what the Ruby comment is, that like there are kind of these generational blips, especially for the less popular languages. Something like Java is a little tricky, where it's an old language, like relatively speaking, yet it's still the #1 language. For a lot of statistics. That's a good question. All right, unless there's like another really burning question, I do want to move on to the really, really crazy stuff. Okay, so yeah, so now we have a bit of an idea of the numbers, but we weren't actually doing like a random number hunt. A lot of this was actually informed by ways that we saw that sociologists might think about these things. And it was opportunistic, but there was some picking here. And so the kind of the other side of our research, we've actually kind of started thinking about adoption in a little bit of a different way, where we realized that it's not just about getting our language out there, it's that we have like kind of these long-standing challenges and questions in programming language research. And so the question is, could we start by looking at them differently, but in terms of social theories, kind of we have alternate explanations for what's going on, or actually in some cases explanations for the first time. And I want to talk about 3 particular cases. The first one is, I think, what a lot of people would expect me to talk about, and is kind of very practical, which is if you are building a language or actually just any tool, how do we kind of market it so people will adopt it? And so there's something called diffusion of innovation that kind of gives us a nice recipe. The next thing is, this is kind of that was sort of like a bit of a narrow-minded view of how adoption works. And for example, one thing I've come to appreciate is through theories like reinvention, what it basically means is the more people use your system, actually the better your system becomes. I'll talk about one particular case of how we might try to harness that. And then finally, I'm going to argue that, kind of pulling on, again, arguments from sociology, that we shouldn't just be looking at the technical side of what's inside your language, that basically a lot of the knowledge about what it means to be a language is actually coming from how people use it. And when I say people, I mean groups of people. So, all right, let's kick this off. So I'm going to say something really bizarre here. So sociologists, if I told them, oh yeah, I think safe sex is kind of like this thing called a type system, I don't think they'd laugh me out. before I get there, before we get to safe sex, let's talk about corn. That's like a little easier. And so basically what happened in 1943 was sort of the beginning of this, near the beginning of this revolution in sociology. And what happened in one particular case study, it was this guy named Ryan, went out from farm to farm, and he looked at how people were adopting corn. And the reason he was doing this is what the corn you're seeing here is actually genetically modified, and more in the tame 1940 sense, not the way we're doing it today. And the reason they're doing this is because they're concerned about things like, say, world hunger. And what they found, what Ryan found, was that it took about 12 years from a farmer to hear about corn that will increase his kind of yield to then for the farmer actually using this on the farm. And all the farmers actually eventually did this. So the question is, why did it take 12 years? So over the next about 20 years, there are a lot of other studies, some about corn, other things about like how children buy toys and how companies buy microscopes. About 500 quantitative studies later, somebody named Everett Roger came into the picture and said, wait, there are lots of patterns going on. I could build a model of how adoption works. And then for the next about 50 years, this became like a really big, wide studied field and cited more than any computer science paper I know of. So I was impressed. So this is a very general thing, so I think you guys will enjoy hearing about this. So how adoption works, as Everett found, was that it kind of goes through a pipeline. The first step, somebody has to hear about your innovation. This, in the case of corn, that's very easy. It's just like a door-to-door salesman went around trying to sell corn. But that doesn't really work. Like, salesmen aren't very compelling. And so what happened is it progressed to the next step, which is something called persuasion. And this is more of like an information-seeking thing. You can imagine going to your social network, talk to your friends about it, go onto the internet, and try to learn more. And this is more of an active process. And eventually, you're going to have to go through this coin flip. You're going to have to make a decision. And this is a very short process, because eventually you're like, yes, I'm going to do this. However, you're not just going to guess I'm going to do this and replant your entire farm. You're actually going to go through a trial period. So here I'm showing that you'll maybe plant one piece of corn, see how that works. If it works for you, maybe you'll try to deploy it on your entire farm. If you're in Alaska, obviously this won't work, so that has to be compatible with how things worked. And so this is basically what Roger found for all these innovations. He's actually very easily able to characterize the processes they went through. Now, at the same time, the person is going through this adoption process, there are catalysts that sort of influence how it goes. So, for example, is the innovation simple? Like, oh, this is magic corn that will have that's resistant to bugs. It's bred to be resistant from bugs. I understand what that does. And well, wait, there's a relative advantage to this. So because it's resistant to the bugs, no bugs will eat my corn, and I can sell more corn. At the same time, you might not believe that this is actually the case, like this is a salesman trying to sell you something, so you actually want to try it out and see that maybe, for example, does my soil type work with this type of corn, and see if it really works. And then for the final step, I just described the final step of compatibility. Does this innovation actually work for your particular domain? Now, the reason I kind of walk through this is, first of all, I think this is actually one of the most important things in this talk. So I didn't even come up with it, but it's still really cool. But the thing is, now we can start analyzing innovations and technologies using those processes and catalysts. So, for example, let's look at safe sex and how that relates to type systems. So if we look at the process, actually, let me backpedal one bit. So the reason I'm talking about safe sex, I actually mean a very particular time period, about early 90s safe sex, which is essentially when you had this whole the HIV epidemic was really concerning. And so if we look at terms of the process of why safe sex was kind of becoming an issue at the time, most people knew that safe sex would kind of prevent problems, and they might actually talk to the friends to say, yes, do you really believe this is going on? But somehow they, somewhere between decision or trying to see if it works for them and deciding to go forward, it kind of fell down. And the interesting thing is, if we look at type systems, most people know about type systems. A lot of people might have even tried to read up a blog entry or something about it, but somehow it falls down. And so if we take a look at the catalyst, it actually seems very similar as well of what the challenges are. So the relative advantage of both safe sex and type systems, oh, we prevent bad things, like you will not die, your space shuttle might not explode. That sounds really good. And it's pretty simple how they both work, right? Like I don't think I need to belabor the point of somewhere like Google. I'm not even talking about crazy type systems. It's just like simple things. However, they also fell down like, when something like observability, did it actually prevent the problem it was advertised to prevent? I don't know. If something didn't happen, why didn't it happen? Like it's hard to see causality, right? And at the same time, for trialability, you can't just use a type system in isolation. You have to work with your coworker, right? Same thing for safe sex, takes two to tango. And so kind of as you go through these things, you actually see that this actually is the same type of technology at its essence. And so the question is, can we learn from kind of studies done in other domains for similar things? So apparently in 2 weekends, you can save a lot of lives. So I'm going to teach you how to do that. Some sociologists took a look at how could we spread safe sex. How do we get this innovation into people's hands and make it active? And so weekend number 1, they actually just hung out at a bunch of gay bars in 3 different cities, and they isolated kind of local opinion leaders in the community. They said, here are the people that people at the bars apparently listen to. What that means, I don't know, but apparently, like why that is, these are the people of interest. And once they found those opinion leaders, they came back the next weekend and said, come to our workshop, let us teach you about what this thing is, and let us teach you how to explain it to other people. And then finally, kind of a cute thing they did also was they actually gave them a little token. So they actually gave them a badge with a traffic light. And so what basically would happen is somebody would say, oh, why do you have a traffic light on your head or on your lapel? And says, well, let me tell you about safe sex. And that was actually very simple, but it got the conversation rolling. I could claim that it worked well, but I can also just show you that it worked well. And so I don't want to get into the methodology of how they measured this, but it's actually much more rigorous than what we normally see in computer science, so I was swayed. But essentially what it comes down to is when they came back 3 months later and also 3 years later, they asked, all right, if you had sex, maybe several times, whatever, did you have safe sex? And more people would say, yes, I did, after the interventions. And then likewise, if they asked, did you have unsafe sex, which is the thing that we're really interested in, and that's where we see it went down. So we have this nice kind of gap. So this was, I think, a very successful case study. So now the question is, can we go back to languages and see, does the diffusion process sort of mesh with how things work here? So we actually have some cool success stories in the kind of language community, and I think I could describe them in terms of this diffusion process. So it's 2 very simple examples. One is observability. Do you see a benefit of this technology? So type systems are supposed to be kind of a program analysis that finds bugs, right? We can't even get people to do this for free, right? That's the kind of the Haskell world. Now, there's a Stanford startup called Coverity that runs program analysis. Not only, and again, it's sort of in a sense the same similar technology, but in this case, not only do they get people to use it, they get people to pay them to use it. And basically what's going on is the analysis runs, and then you see that this long-standing bug or this really scary-looking bug actually gets characterized. So that's an observable result of your tool. That's something you want. So the question is, can we do this for type systems? How would you do that? Can you give some accountability? Another case here, and actually probably really big at Google, is something like relative advantage. If I use this tool, do I really see, like what do I expect to see in terms of a substantial change to myself or my organization? So something like Hadoop or EC2, all of a sudden, oh, I'm going to scale out, I'm going to be able to handle more users, things like that. And so this targets a particular need, and it's a very quantifiable need. And so relative advantage is something you should be thinking about when you're trying to design your technology, like if you want people to actually use it. So I can go through all the other catalysts and all the other processes and do the same thing for for other popular technologies of the day. I suggest you think about it, and then if you really are stumped, then maybe look at the slides, but I think you should just think about it. Okay. I just described very technical solutions, but what was kind of really cool to me about the safe sex advocacy was it was very non-technical. They just went to a bar for a weekend, right? We actually have that in the computer world. For example, I don't know, This luckily is no longer true. We dropped the URLs now, but you actually could look at a website and see what technology they use. And this is a ringing endorsement for your technology. People know about it. They get persuaded. So I think a lot of simple solutions will work. Just you have to think about them and know how to think about them. OK, so this was about how to get people to use your technologies and ways of thinking about it. As a language designer, or as an academic, that sounds fun, but that's not the only thing I'm interested in. I just want to make better and cooler things. And so actually, I'm going to argue that adoption lets you make better and cooler things. So I'm going to look at one particular case and something called Reinvention. And I'm going to look at something in the context of something called living will law. This is a very politically charged topic. So, but what instead of getting into that, what I do want to say is that both Republicans and Democrats in the US think this is an important thing, and so both do lots of legislation on this. And there are a lot of points where they agree that essentially you need to have laws about what happens when somebody's in a coma, like what are their legal rights. And what was really, so as a Californian, I was very excited. California wrote one of the first living will laws. That's good. And then very soon after, Nevada wrote another living will law, and they actually expressly said, the goal of this legislation is to become in accordance with recent California legislation, a living will law. So actually, they had no innovation in this law. It's just like the same thing. It's just copy and paste. But the really surprise thing is about 10 years later, Arkansas, which is not liberal hippie California, had made its own living will legislation. And what's more, it was actually better than that legislation that California had in 1976. So question is, what happened? And kind of cool is this actually isn't a singular event. If you look at something like school policy, or maybe if you don't like welfare but you want people to go off welfare and get jobs, that's something called welfare reform. There's actually the same curve that happened for how as policy spread throughout the country that it got better. And so,
what is your vertical axis? How are you measuring that?
It's very law specific. The case of living will law, the question is, does it handle more scenarios that come up, and how easy it is to actually, independent of whether you can or cannot do something, how easy is it to exercise? So think of this like a flexible type system. Like maybe it does what you want it or not, but it's flexible. It gets you there really quickly. I'm going to stop making fun of type systems. I've written a paper about them, so don't think I'm against them. What's really going on here is actually two very cool phenomena that I think we should be looking at. One is something called social learning, where basically this is kind of Arkansas looking at somebody who did a full deployment of the idea before, and you can just see how that worked for them. Can we copy the good things, change and fix the bad? And kind of related to that is something called adaptation, where you don't want to, you're going to be in a different context than the person using the innovation before. So in this case, for example, if the legislation was made for an urban area, now that it's because you're in a rural area, you're going to need different legislation, and so then you're going to have to adapt it based on your context. So both of these phenomena, you can learn from them and see how people work in those scenarios. This is very hard to do in a lab room environment. So if you're designing a language, I think it's actually a very good question: is how can we harness kind of this reinvention in the community to be part of the language design process or the future process? And more in general, if you're making technology, you could pretend you can invent it all, but I'm going to say history is against you. So to be very concrete, how this shows up, like as Leo the language designer, I'll come up with an idea. I'll maybe prototype something 3 to 9 months. Maybe I'll send it for 3 to 6 months to people to feedback, see if they like this language feature. Then maybe I'll have to iterate again, and so now we're kind of entering this year-long period, and then heaven forbid I decide to publish a paper about this thing, like that's like an extra year-long lead on working on this feature. This is kind of where we are in the language design community today. Even kind of an industrial setting, like it's a little faster, but it's actually not significantly faster. And so the kind of question is, how do we streamline language evolution so you actually can involve the community to actually improve your technology? So this is a thought experiment. I want to be clear that I'm not doing this, but this pulls on to a lot of ideas people are doing. So again, let's say we start at the top with an idea. Now, then you're going to want to design your language feature, but you're not really interested in all the heavy, gunky, low-level details. So notions like language as a library, where you can do kind of a interpreter level or very high-level implementation of feature, that actually streamlines the process. And then from there, you can actually go and get it out into the community right away. But however, today, you can't just, you can put it on a blog, but who's going to use it? So the question is, if you're actually working with the language community, how do you actually engage with the language community? And so, for example, we have Mechanical Turk, which will give you, people who, I don't know, work at a call center. That's not very interesting. But you can ask, is there kind of a Mechanical Turk equivalent for trying out language features? And as far as I can tell, there is not. So if you want to build one, please let me know about it. But that's not enough. Then you have to actually get the data back from these experiments, right? If you actually want to learn from how the community works. And so there you need to get analytics from your compiler. Maybe you actually have to, as you saw in the beginning of the talk, you actually have to survey people to see what's going on. Like, not everything is just in the numbers. Like, there's explanations for the numbers. And then finally you realize that we're iterating. And so you actually want to put this all into a central place, save that data for somebody else, fork, and on the next pipeline. And so I'm not saying this is necessarily the way to do it, but hopefully by that principle of social learning, you kind of appreciate, oh, there is this untapped resource that we don't know how to take advantage of today, and for a lot of other people, works for us. Mark is making eyes at me.
Yeah, so back up a second. So many languages have active communities that seem to me to already be providing your expert social trials kind of function. Right? I mean, the Python community has their own PEP process. When I was growing E, there was this very active community list, and we were constantly discussing language features. Today, ECMAScript has a very active community. Find these communities of discussing and proposing and prototyping features and providing feedback and iterating fairly quickly differ from this picture.
Yeah, so that's actually a very excellent question, which is basically, we already have involved communities. Do we want to involve them in a different way? Is this that type of involvement I'm talking about? And so through there, I actually want to draw on an example. I was talking to one of the Scala developers, and particular a concern that they've been having, which is Scala is this language that's going under rapid kind of evolution as we speak. What basically happens is somebody like Martin Odersky will have an idea, and they'll put out a patch or talk about it on the mailing list. But what they realized pretty quickly on was that essentially it's an echo chamber. That you're talking to this like very special demographic, and that this does not necessarily relate. It's unclear how this demographic relates to the demographic you actually care about. And so when I'm talking about social learning, I'm really saying get this out to people, the community or representative of the community who actually really are working there. And so I think, for example, ECMAScript, we're doing a really good job of, for example, getting high-level developers at Google and at Microsoft to say what they want in the language. But unfortunately, those aren't the only people using the language. And I'd say those are the minority. And so I don't actually have a solution for you, but I do have a problem for you. Or I have a proposal for a solution. This is totally untested. So yeah, that's a great question. Okay, so I want to go now I want to go super high level. So I talked about different ways of using adoption for some particular tasks. Now I'm going to actually argue that this shouldn't just be Leo coming here and talking to you about it. So I think other people should be looking at it. And I want to give two examples of why this was, I found this interesting. So here we have something called an ecological theory. Somebody named Mark about, I think 15 years ago, asked an interesting question, or actually made an interesting observation, that discussing music with your friends is fun. And so what kind of led from that is, well, does this somehow drive how we pick music? And how music genres emerge. And what he kind of observed is that individuals have time constraints. You can't just listen to all the music or talk to everybody about your particular music and seek them out. And what he realized is that somehow it moves along music moves along demographic lines in a pretty interesting way. And so what you're seeing on that chart on the left is, on the x-axis is people's age, and on the y-axis, people's education level. And so, for example, if you look at person A on the top, they're somewhere in that middle age group, but they're very, very educated. And what's kind of cool is that you can actually start drawing kind of niches around which people listen to what music. So even if you don't know anything about person A, there's a good chance they like, or at least according to this graphic, they like new age music. if you look at somebody kind of older, person B on the right, they're part of a much bigger demographic, big age demographic, and that actually country music, I was sort of surprised by this, is actually very popular in the US even before the recent bluegrass stuff. And then part of the appeal is that it's actually for a lot of people, according to this reasoning, is that actually a lot of people can talk about each other to country music and know what they're talking about. And so what the realization behind this chart I'm showing you here is that when some sort of innovation, whether music, technology, whatever, is kind of competing out there in the market, it's actually not competing for individuals, but competing for social networks. So the case country music has won the demographic of people who are older, while heavy metal has this nice niche of younger people. And so when the interesting thing is, if I go back to this early graphic I showed in the beginning of how languages spread throughout SourceForge, I kind of said that, oh, DSLs are going niche by niche. I'm actually going to make a much stronger claim that according at least to the ecological theory, if you're a language designer, you're actually not targeting the technology constraints of a niche. You're more generally targeting, you're actually a community builder. That you might actually not necessarily have even fixed any technical problems in that niche. According to ecological theory, you've just somehow spread into that particular social network of the domain. So when I say domain-specific language, I mean community-specific building or something like that. So this is kind of changes exactly how we evaluate or understand languages, right? And so now I want to finish on kind of one last example. I don't know if, I grew up in New England, and we like to make snowmen there. And I don't know if you ever made one, but you kind of roll the snow, and every time you roll the ball, it gets bigger and bigger, right? And technology is actually kind of like that. In particular, let's say you make one roll and you add in some technology on top of the existing technology. What this is going to do is enable new types of social interactions. For example, oh, we added a Twitter wall or something, or a Facebook wall. Now all of a sudden, people standing in line at the market can tweet on it, and that means they have new social interactions driven by the technology. But at the same time, if we turn the snowball again, now we're going to actually have, based on those social interactions, new types of technology emerging. And for there, I might say, for example, before we had Twitter, we had Facebook. And so because people were using Facebook, then we were able to advance to Twitter. And the kind of relevance here is that if you want to talk about designing a language, building some new technology, that's only half of the kind of the ball roll. The other half of the ball roll is actually understanding how people are using it, and that actually tells you how the next iteration of the technology works. And this is kind of good news, bad news. Good news is that, oh, we have this understanding, or I claim there's this relationship. Kind of the bad news is twofold. One is this relationship is a moving target because they're kind of codependent. It's kind of human specific. It's society specific. And the really bad news here is I don't think sociologists are going to do the work of understanding the other side of the ball roll for us. So if you really want to understand this, I think I have to keep doing this. Other people have to keep doing this, and we actually have to be a little more. I would claim scientific about it, but at least just looking at it somehow. So kind of in conclusion, I kind of showed you two things. I don't think this is actually a conclusion. I think this is actually a start of a lot of cool stuff. The first thing is I think we are in a data era of language research. It's not just software engineering or analytics. I think it's actually how we get data to understand how languages work. It'll hopefully be not as much of an art going forward. And the second thing is I think when I talk about principles of programming languages or language foundations, my argument here is that social theories are actually one of the big foundations that for a lot of the things we actually care about in languages, the social theories actually inform whether they work or not and how they should work, and they actually give explanatory explanations. So with that, I want to say, if you thought this was cool, go to my website. I have data, papers, and an email link probably somewhere there if you want to talk more. John? Well, okay, then let's harken back to the safe sex example. Apparently, people on their own aren't gonna get pushed to do safe sex, but somehow if you actually kind of hijack the social process and interject on it, you can change it. So there's actually really bad news here. which is one of the kind of early results from kind of like the modern school of sociology, was that a lot of these kind of social processes are not automatically self-sustaining. That even if you do an intervention, it's actually to design an intervention that keeps working is actually very hard. So kind of good news, bad news. Good news is interventions work. The bad news is it's hard to actually do them. Actually, one last thing here. I was actually very impressed by the age invariant result, because actually what it told me is that kind of older programmers are like they actually have a very long shelf life. Like, you know, a 60-year-old knew all the popular language. Like statistically, it was fine. Maybe there's some sample bias here, but I actually thought that to be a very promising thing that they were on it. Oh, hey.
On that age thing, I mean, how much do you consider the fact that people shift the set of languages they know? I mean, when I was 15, I knew BASIC very well, but if someone asked me today, I probably wouldn't list BASIC at all.
Yeah. So the question is like, how clear was how do we discern languages from before versus languages they're using actively today? There we had two different questions about that, and we put them in a particular order to help. And the first question was, what language have you ever used? And like, even if before, and we were careful with the phrasing to get at that. And then the second question is, what languages do you know well now? So I'm totally with you on that. I think there's still problems with the phrasing, but actually, wow, Mark and John, like, yeah.
Core is a useful thing, but we don't believe in core, right? It's not like a lease structure. But in programming language, we kind of have this belief thing going on. Like, now, you don't have a type check, you don't have a language. There are some people on the other side. So it's kind of a belief thing going on. Belief structure is much harder to shift, much harder to see. Get people to adopt and listen to what's very valuable.
Yeah, so I think that's a very good observation, which is that basically languages may not necessarily be an entirely technical innovation, that like there's still some perceptions and beliefs involved. And there actually, I found two very compelling areas of research that helped kind of align my thinking there. The first one was historical linguistics, which is asking questions like, well, why was Italian so popular after the Romans? And it's not because Italian is a better language, but it's because, well, you know, if you work in the Roman army and learn whatever, you'll become a citizen. So there's there's kind of, that was like an issue of prestige and other things. The other community, which actually, it's a smaller body of research, but also very interesting, is something called the economics of religion, where you get a statistician to actually ask how a religion works. And there we get funny results, like, for example, if you don't care if your language is adopted in wide scale, but you are interested in if people keep using it. So, for example, you can do horrible experiments on them, which actually I think is a great model for academia. You can be a very strict and very polarizing religion or language, and if you make it hard for people to get in, but then once they're in, it's hard for them to leave because like all your libraries don't interoperate with anything else, people will stay. And then you can try things on them. So like I totally agree with you that there's like a lot like non-technical going on, or non-utilitarian. In the middle.
It sort of feels like the great area of language explosion was back to the 60s, perhaps, or the 70s. And everything we're seeing now is, oh, well, let's take something from the 60s or 70s, redo it with a C syntax, or dumb it down so that more people can go for whatever. Like, is that a reasonable observation? And so
That's how all computer science works.
That's happened in the 60s. Okay. But seriously, it's like you're arguing over the details in a sense. It's like the difference between sect A religion and sect B religion. But way over here is something that's got a totally different view of the world, and you're totally ignoring it.
Right. Yeah. So I think that's kind of what motivated a lot of this work, was that I think it's sort of like not quite the same problem that physics has today, like, but we're getting there where our ideas are way past what people could actually do, or what people will use. But on the other hand, I actually don't think when I look at numbers, like actually that the programmer today uses many more languages than they used before. Whether those languages are actually very different from the ones they used before, that's a good question. And it's definitely, for example, the research I do for the language features I do, like those aren't going to show up in your language in a very long time. That's also kind of why I think we should understand this. Like I don't want that to keep happening. Mark?
So on your diffusion of innovation, enumeration of the characteristics of pump adoption, there was all this stuff about compatibility and trialability. And then you're focusing on type systems. It would seem, I would have expected that the focus would have, the purpose that you're imagining one is trying to advance is to promote type systems to programmers that currently are in dynamically typed languages. That gradual typing approaches and optional typing approaches, things that allow the types to be adopted incrementally and allow them to be used in the context of not having to completely change what base programming language you're using. I would have expected that to have all followed from your basic principles.
Yes. So the kind of question is something like gradual typing, which lets you mix in static types into your dynamic language. Let's make this the last question, actually. But yeah, so the question is like, how does gradual types, which is supposed to be a kind of adoption-oriented approach to static types and mixing those into popular dynamic languages, does that work or not? I think in many cases it does address a lot of issues. But for example, can you imagine working with 3 people? One of them doesn't know anything about static types, and the other 2 do use the gradual types. Could the person who doesn't understand static types very well actually write programs that interop with them? My claim is actually with modern gradual type systems, the answer is no. That's my experience with doing something similar at Adobe.
Okay, so let me just, I think the reason the answer to that is yes, is the very common observation that the main purpose that declared types have is documentary.
Yeah. So that's like a slightly different issue, and that is what's the purpose of these types? And I agree with you that actually.
That's a bridge for the person who doesn't think in terms of type checking. That bridge will enable him to work well and will enable the incremental learning without having to explain the concept.
Yeah, and our statistics agree with that, where we found that when we asked actually people why they thought static types are good, they actually didn't think static types were good for bug finding. They thought unit tests generally were better, but they did think static types were good for explaining things. So maybe that's what the static type community should look at a bit more strongly.
Well, thank you so much, Leah.